is n. And we follow the same principles. Get everything into index form to start with. That's the key strategy that we need to follow, and you'll see that especially when we look at the last numerical example from question 2. Okay, in index form, that would be the indefinite integral of t minus 3 to the power of 3 on 2 with respect to x. The cubed, this 3 comes from the cubed. The fractional, the denominator of 2, comes from the fact that this is a square root. A square root is to the power of a half. So we have a power of a half times a power of 3. And when you've got a power of a power, you multiply them together and we get 3 on 2. So that's a really brief review of index laws from year 8, I think actually, year 8. Now when we do the integration, we'll have t minus 3 to the power of 5 on 2 all over, well, the coefficient of the t term, ooh, big mistake here, big mistake. I've got dx just fixed in my head and just keep on doing dx, dx, dx. The truth is that this function is a t, that's a typo. This shouldn't have been with respect to x, this should have been with respect to t. It's not with respect to x, it's with respect to t. That's the function that we've got. So that's a really important thing. Don't make that error, or if you make that error, make sure that you correct it like I've just done. Okay, and we will have, as our final solution, t minus 3 to the power of 5 on 2. The coefficient of t is 1 times the power is 5 on 2, and then plus c. So our final answer would be 2 outside of t minus 3 to the power of 5 on 2 all over 5 plus c. Okay, I'm running a little bit short for space, but we'll see how we go with cramming in these last 2 examples. They're both going to be numerical examples where we evaluate. It's from question 2 in exercise 3.5. Let's see how we go. Question 2. 2a has the integral of 2x plus 1 all to the power of 4, and the limits of integration are from 1 to 2, and this is all with respect to x. Follow the pattern. We're going to end up with 2x plus 1 to the power of 5 all over 2 times 5, and the limits are from 1 to 2. Remember that now that we have limits of integration, the c disappears. It's no longer going to be a problem for us. I went through the explanation for why that is in class. If you're not sure about why that is, then by all means feel free to put a c in there, expand a whole lot, and find out what happens to the c every time you do the evaluation. And you realise the c just isn't important. I'll leave that for you to do. I've already shown you once in class. So this will now be, we substitute in the values of x into our expression. So that will be 2 substituted into here, so that will be 2 times 2 plus 1 to the power of 5 all over 10 minus 2 times 1, I'll put time signs in there, plus 1 to the power of 5 all over 10. Okay, so this will be 4 plus 5, 5 to the power of 5. Let's do this in our heads. I think I can do this. 5, 25, 125, 625, 3,125, I think. 3,125, I don't have a calculator on me in my brain. Look, let's just hope that I'm right. But you get the idea, it's 5 to the power of 5. That's what we've got. 5, 25, 125, 625, 3,125. I'm pretty confident about that. All over 10, and that's going to be 2 times 1, which is 2 plus 1, 3, 3 to the power of 5. I don't know, 81, 243, it's one of those ones. 3, 9, 27, 81, 243. minus 243. And you can find out what the numerical answer is for that. Alright, I might actually just do the last example down in this space at the bottom here. You can zoom in on this if you want with your screen, hopefully, and see what's going on. So the last example, quite an important example, is question 2J. All right, and what we have is the integral from 1 to 4 of 2 over the square root of 5x minus 4 to the power of 3 with respect to x. Key first thing is get all of this in index form first. Right? Now that's in a denominator, it's a square root sign, this is cubed, so this 5x minus 4 will be 5x minus 4 to the power of minus 3 on 2. Alright, so we're integrating from 1 to 4, and it's going to be 2 times 5x minus 4 to the power of minus 3 on 2 with respect to x. And if we move up to here, that will give us 2 outside of this constant multiplier. It could have been taken out the front like I did over here, but I'm just skipping a step now, okay? The constant multiplier goes outside the square brackets, and it'll be 2 outside of 5x minus 4 to the power of minus 3 on 2, and the limits of integration are from 1 to 4. That gives us 2 outside of, we'll have 5 minus 4, oh no we won't, we'll have, sorry about that, when we substitute the 4 in, we'll have 20 minus 4 to the power of minus 3 on 2, minus 5 minus 4 to the power of minus 3 on 2. Now just a note is that 5 minus 4 is 1, and 1 to any power is just going to be 1. So that second part of the expression there is just a 1. This first part is going to be 20 minus 4, that's 16, and it's 16 to the power of minus 3 on 2. First of all, let's forget about the fact that it's a negative indice. Let's just think about the 3 on 2. 16 to the power of 3 on 2, that's like saying either the square root of 16 cubed or 16 cubed and find the square root. It doesn't matter which path you take. For me, it's easier to go the square root of 16 and cube it. 16 to the power of a half and then cube it. So 16 to the power of a half, square root of 16, that's 4. And 4 cubed, that's pretty easy, that's 64, that's quite common. So this expression here, forgetting the negative indice, this expression here is going to be 64. But the truth is, it's actually a negative indice, so it's 1 over 64. Now what that means is we have, over here, we have 2 outside of 1 over 64 minus 1. 1 over 64 minus 1 is going to be minus 63 over 64. And we have 2 of them. It's going to be minus, this 2 can cancel out with the denominator of 64. So we'll have minus 63 over 32. Minus 63 over 32. Now in the textbook it may end up giving you a mixed numeral, but whether it's a mixed numeral or an improper fraction, there's still the same numerical value. Okay? Practice these ones, get lots of practice.